टुडे वी विल डील विद प्रॉपर्टीज ऑफ एल्केन। आज हम एल्केन के गुणधर्म के बारे में अध्ययन करेंगे। एल्केन up of 4 carbon atom are colorless, odorless gases. Alkane from C5 to C17 are colorless, odorless liquid, and above they are colorless, odorless solid. Alkanes are non-polar molecule, therefore they are insoluble in water but soluble in organic solvent like CCl4, benzene, and ether. Melting point and boiling point. Density increases with the increase in number of carbon atom. With the increase in one carbon atom, there is an increase of boiling point up to 20 degree K, but increase in melting point is irregular. It is given in table 4.3. Alkane containing even number of carbon atom have higher melting point than nearby alkane containing odd number of carbon atom. Arrangement of carbon atom is even and odd. Number of carbon atom containing alkane is as shown. Arrangement of carbon atom in alkane containing odd number of atoms, and here arrangement of carbon atom alkane containing even number of atoms. Alkane containing even number of carbon atom have terminal methyl groups on opposite direction. They are arranged in crystal lattice, so intermolecular attraction increases. Hence, their melting point are high. On the other hand, alkane containing odd number of carbon atom have terminal methyl groups on same side. Due to some symmetry in crystal lattice, they are not arranged properly within the crystal lattice, and hence intermolecular attraction is weak, so their melting point are less. So increase in branching in isomeric alkane, there is increase in melting point and boiling point. As the chain increases, difference in melting point and boiling point decreases, as shown in table 4.4. Methane and ethane are odorless gases. More volatile alkane have odor like benzene, but less volatile alkane are colorless. As the molecular weight increases, the relative density increases, but for higher alkane it remains constant. Next is halogenation. If one or more hydrogen atom of alkane are replaced by halogen, it is known as halogenation of alkane. With chlorine, it is known as chlorination. With bromine, it is known as bromination. With iodine, it is known as iodination. And with fluorine, it is known as fluorination. The reactivity of halogen decreases in the following sequence. That is, fluorine is more reactive than chlorine, which is more reactive than bromine, which is more reactive than iodine. Methane react with chlorine in diffused sunlight at 573 to 673 degree Kelvin. It forms chloromethane. This reaction continues till all hydrogen atom of methane are replaced by halogens. Methane react with chlorine in direct sunlight. It forms carbon black and HCl. According to Victor Mayer, in ethane and higher alkane, substitution of hydrogen takes place from adjacent carbon atom one by one, as shown in bromination of propane. A reaction of alkane with iodine is a reversible reaction. Hi formed as product in the reaction is powerful reducing agent which reduces iodoalkane. So to prevent it, this reaction is carried out in the presence of HiO3. It converted Hi into iodine and water. The reactivity of different hydrogen atom towards halogen in an alkane is in the following sequence, that is tertiary hydrogen is more reactive than secondary hydrogen, which is more reactive than primary hydrogen. Mechanism. Halogenation of alkane is a chain reaction. It takes place via free radical mechanism. It completes in following three steps. First is chain initiation. Here the Cl2 molecule on exposure of UV radiations at 573 to 673 degree Kelvin, it forms chlorine free radical. Chain propagating step. Here chlorine free radical react with methane, it forms HCl and methyl free radical, and this methyl free radical again react with chlorine molecule to form chloromethane and chlorine free radical. This step is repeated unless most of the methane is converted into chloromethane. Next step is chain terminating step. By the combination of free radical with themselves, reaction gets terminated. That is, chlorine free radical forms Cl2, methyl and chlorine free radical form CH3Cl, and methyl free radical forms ethane. This is chain terminating step. Nitration. When alkane react with nitric acid, vapors at 673 to 773 K temperature through free radical mechanism, mixture of all possible nitroalkane is formed. That is, propane on nitration gives a mixture of 2 nitropropane 40%, 1 nitropropane 25%, nitroethane 10%, and nitromethane 25%. Sulfonation. Higher and lower branched alkane react with fuming sulfuric acid to form alkane sulfonic acid. Lower unbranched alkane do not react in this reaction. Hydrogen atom of alkane is substituted by sulfonic acid. Substitution of hydrogen atom of alkane by sulfonic group in the following sequence, that is, tertiary is greater than secondary, which is greater than primary. We can say 2,2-dimethyl propane on treatment with sulfuric acid forms alkane sulfonic acid. Incorporation of methylene group. Lower alkane react with ketene or diazomethane in presence of UV light and forms a mixture of higher alkane. At the time of reaction, CH2 is obtained from CH2, that is ketene or diazomethane. Next is chlorosulfonation, or we can say Reed reaction. Alkane react with sulfur dioxide and chlorine in the presence of UV light, form alkane sulfonyl chloride. In this reaction, hydrogen atom of alkane is substituted by sulfonyl chloride group, that is SO2Cl. Ethane on reaction with SO2 and Cl2 leads to the formation of ethane, sulfonyl chloride and HCl. It is used for the industrial preparation of detergent, pyrolysis or heating. Higher alkane in absence of oxygen at 773 to 973 degree Kelvin decomposes to form a mixture of lower alkane, alkene and hydrogen. For example, propane on heating at 773 to 973 degree K forms propene, ethene, methane and hydrogen. This process is known as cracking. Pyrolysis takes place via free radical mechanism. It can be explained by taking example of propane. First is chain initiation step, in which butane on providing UV radiations, it forms ethyl free radical or propyl free radical or methyl free radical. Next step is chain propagating step. Free radical formed in the first step abstract hydrogen atom from alkane. This free radical breaks up into alkyl free radical and alkene. And the third step is chain termination step, in which two alkyl free radical forms alkane and hydrogen. Next is dehydrogenation. When alkane are heated at 773 to 973 degree K in the presence of molybdenum, vanadium, titanium, selenium oxide, alkene and hydrogen are formed. For example, ethane on heating in presence of catalyst alumina at 773 to 973 degree K, ethene and hydrogen is formed. When 6 or more carbon containing alkane are heated in the presence of chromium, molybdenum or vanadium oxide at 673 to 973 degree K, and at high pressure aromatic hydrocarbon are formed. It is known as hydroforming or catalytic reforming. That is, we can say also aromatization or catalytic dehydrogenation. That is, we can say hexane on treatment with alumina at 773 to 973 degree K or high pressure, benzene is formed. This is known as aromatization. Next is isomerization. When normal alkane is heated in presence of AlBr3 or HBr or aluminum sulfate and sulfuric acid at room temperature, its isomer are formed. This process is known as isomerization. For example, normal butane, when treated with aluminum bromide or HBr, leads to the formation of isobutane. Normal pentane, on treatment with aluminum bromide or HBr, it forms a mixture of two isomers, that is isopentane and neopentane. This process is known as isomerization. So, this is all about properties of alkane. Thank you.